Hello students, let us see the new concept, that is braking of induction machines. Okay, so you already know what is the braking. Braking nothing but stopping a motor or stopping any vehicle while it is running, that is braking. Okay, stopping the motor while running is called braking. So far we have known the starting methods. We have started the machine using auto transformer starting or DOL starting, direct online starting, and the start delta starting, like etc. Okay, we have started the machine and we have run the machine. So far we have done that. Now we are going to stop the machine while it is running. So why do we need to stop it? So the simple example is, we have the applications of induction motors. Almost 70% of industry is using induction motors for any applications. The examples of applications are lifts, elevators, and so many drives in industry. So their drive may have to stop for some time and they have to run for some time. So there are so many different types of drives in industries now. So we need to make sure that we have to stop the machine whenever we want to stop it, and we have to make it rotate even in the opposite direction, so that so many applications can be achieved. Okay, we have to make our induction motor to stop whenever we want to stop it. So there are two types of braking actually. So braking can be done mechanically. Braking can be done mechanically by applying brake drums, like one we use it our two-wheelers or cars. Okay, we use for automobiles. Mechanical braking is automobile braking. Okay, automobiles use mechanical braking. Okay, and another type of braking for our electrical motor is electrical braking. Okay, this is for electrical motors. Okay, the braking is two types. One is mechanical braking and electrical braking. Okay, mechanical braking is nothing but applying braking drums onto the running machine, but electrical braking is nothing but by manipulating some electrical quantities we can stop the machine. Okay, that is electrical braking. And even for electrical braking we will use our mechanical braking as standby braking. Okay, mechanical braking is standby. If our electrical braking fails, our mechanical braking will be applied, and even after applying electrical brakes, our mechanical brakes will be applied after applying electrical brakes. Okay, that I am going to explain later. So let us take an example of a lift. Okay, elevator. Okay, if I have three floors. This is my first floor, second floor, third floor. Okay, so this is my lift elevator here. So somebody pressed the button here, so the lift starts coming down, and it has to start at a position where it matches with the floor number. Okay, so it has to come down and it has to stop here. So how can you stop exactly at the floor number? So that is done by our electrical braking. First, electrical braking will stop the motor speed. That means electrical braking will make the motor speed 0. Then after, mechanical braking will be applied. Mechanical brakes will be applied to hold the machine. Okay, so this is application of electrical brakes and mechanical. First, electrical braking will make the speed of the rotor shaft equal to 0, and then our mechanical brakes will be applied to hold the lift at exact position. Okay, and if you don't apply electrical braking, if you only apply mechanical braking, your brake drums will burn out, because the rotor will continue to rotate, because we have supplied the machine and it has inertia. Even if you cut the supply, even if you turn off the supply, you are supplying 3-phase, right? Even if you turn off the 3-phase supply, due to the inertia of the rotor, okay, it will try to rotate. So for that you have to make sure that our rotor speed should be 0 before applying mechanical brakes. Okay, so how can you make rotor speed equal to 0 is our concept. Okay, rotor speed or rotor torque equal to 0. Now let us see, there are three types of brakings here. First one is regenerative braking. Regenerative means it will generate the power back to the supply, that is degenerative braking. Second one is plugging. Plugging means we play with some plugging methods, okay, which play with some phase sequence ABC to ACB. And the dynamic braking means we have to apply some resistance load. So this is about types of braking. Now let us see one by one. First, let us take regenerative braking. Let us see regenerative braking. Okay, so we have to stop the machine while running. So for that, here I have considered the synchronous torque slip characteristics of our induction machine. The torque slip characteristics, induction machine. Okay, so this is the expression for our synchronous speed of the machine, 120 F by P. So now look at this. If somehow I manage to change the frequency by keeping V by F ratio constant, so that our machine won't affect with magnetizing current. Okay, if I somehow manage to reduce the frequency by keeping the V by F ratio constant, so what will happen to our synchronous speed? Let me consider it as NS1. Okay, that will become 120 times our reduced frequency is F1. Okay, by number of poles. So F1 is reduced frequency, which is less than our supply frequency. Yes. Now I have reduced the frequency of the supply by keeping V by F ratio constant. I have reduced the frequency by keeping V by F ratio constant. Now you can see that our F1, which is reduced frequency less than supply frequency, so this is a new speed of new synchronous speed with F1 frequency. That means let me consider our torque slip characteristics for our new synchronous speed. Okay, so that will be like this. Okay, and you can see that the machine is going into generating mode. Okay, so here this was the earlier speed of the machine. Okay, this is my NR, speed of the machine. Now due to the change in frequency to F1, okay, the characteristics of torque slip are like this. Okay, that means this is my new synchronous speed, this is my new synchronous speed NS. Okay, and you can see that our new torque slip characteristics met with load torque here. That means this should be our new speed of the rotor. Okay, just I have changed the frequency of the supply, but I have reduced the frequency of supply. Our torque slip characteristics has been shifted left side. Okay, here you can see this is my new synchronous speed NS1, here this is my NS1. Okay, and this is my new speed of the rotor. Initially it was the rotor speed, now it is reduced like this, and our rotor has been rotating while we have changed the frequency. So it cannot shift back to this speed, it cannot reduce the speed abruptly because the rotor of the machine has some inertia. Okay, inertia of rotation doesn't allow rotor to slow suddenly. So what will happen? Our rotor speed will shift to this new operating point. Initially this is my new operating point A. Okay, now it has to come to this B operating point because the reduced frequency, but our new operating point just after reducing the frequency under transient condition will be at point C. This is my new operating condition under transient position just after changing the frequency. Here you can see that our rotor speed will now tries to reduce back to our new rotor speed at position B. Okay, as time progressing, our rotor speed tries to reduce slowly. Now it comes to a point O here. This is my point O. Okay, here you can see this is nothing but our synchronous speed condition. Here the slip will be equal to 0. Okay, NS1 at NS1 our slip of the machine equal to 0, and due to slip equal to 0 our current will become 0. Due to current become 0, torque will become 0. Okay, so all are 0, all have become 0. So at this position I am going to turn off the supply to the machine, supply to the motor. Okay, then our machine will come to stop. That means I have braked the machine. Okay, I have braked the machine just after switching the frequency from F to F1. So this is nothing but regenerative braking, and you can see that here this is generating mode of operation for NS1. Generating mode means our speed of the rotor is greater than NR greater than our new synchronous speed NS1. That means our slip is equal to NS1 minus NR by NS1. Okay, so here NR is greater than NS1 at transient period, at this period. Okay, NR is greater than S, that means slip will be negative. Okay, for slip is negative, we consider our machine is operating in generating mode. Okay, so for generating mode NR is greater than S, and our machine will generate some power, and that will be supplied back to the supply, that will be fed back to the supply. Okay, this will be fed back to the supply for period of C2O. For while our NR is reducing from C to O, our supply will be fed back to grid. This is nothing but regenerative braking. That means we are generating some power and feeding it back to our supply lines while it is coming from C to O. So this is nothing but regenerative braking. Most of the trains, metros are using this type of braking, so that while braking it can pump the power back to the supplies. Okay, so while braking it is acting as a generator. That is the concept here. So a generator delivers electrical energy back to the supply. So this is about regenerative braking. In the next class we will be dealing plugging. Okay.